Okay, we're going to pick up on your review with number 13 for the function. Find the maximum number of real zeros that the function can have, the maximum number of x-intercepts that the function can have, and the maximum number of turning points the graph of the function can have. So when it asks about the maximum number of zeros, that'll always equal your highest power or the degree of that function. Same thing for maximum number of x-intercepts. That's also the highest power. It doesn't mean that's how many it's going to have, but that's the most it could possibly have. And for the maximum number of terms for that function, it's whatever your highest power is minus 1. So in 13, if we have f of x equals 2x cubed plus 8x squared minus 6x plus 2, since the highest power is 3, the degree of this function is 3. That means it could have 3 zeros maximum. It could have 3 x-intercepts maximum, and at most it could have 3 minus 1 or 2 turns. 3 zeros, 3 x-intercepts, and 2 turns. So my answer would be C. For 14, f of x equals 15x to the fourth minus 8 plus 0.14 x squared minus 8x. So here's our first term. Our degree is 4, so it could have 4 zeros maximum. It could have 4 x-intercepts maximum, and it could have at most 4 minus 1 or 3 turns. My answer again for 14 is C. All right, 15. This one's kind of a little bit, 15 and 16 are difficult. They want a polynomial function of degree 3. That means it's going to have 3 factors with -2, +3, and +5 as zeros. So that means my factors would be x plus 2, because that would give me -2 as a 0, x minus 3, and x minus 5. All right, so we've got the 3 factors, x plus 2, x minus 3, x minus 5, and we have to multiply them together. It really doesn't matter which 2 you multiply together first, but since these both have a minus, I'll do those. X minus 3 times x minus 5 will be x squared, and then I'd have minus 5x and minus 3x. That makes minus 8x, and then plus 15. So now I'm going to multiply x times all of this, and then 2 times all of this, which is x cubed minus 8x squared plus 15x, and then plus 2x squared, and then 2 times minus 8x will be minus 16x, and then plus 30. Which is x cubed minus 6x squared. That's putting minus 8x squared and plus 2x squared together. Minus x, that's putting 15x and minus 16x together, and then plus 30. And so that is your function that has it has degree 3, and it has the zeros -2, 3, and 5. And then 16 I should have here somewhere. Let me scroll through here. 16 says it's degree 4. I have -3 is a 0 with multiplicity 2, -2 is a 0 with multiplicity 1, and -1 is a 0 with multiplicity 1. So what I do is I write x plus 3 down twice, and then x plus 2, and then x plus 1. And I multiply those together. The easiest way to do it is to multiply the first two. So x plus 3 times x plus 3 is x squared plus 6x plus 9. And x plus 2 times x plus 1 is x squared plus 3x plus 2. If you do the outers and the inners, you get 3x. The last is times 2. And so then you've got to multiply this trinomial times this trinomial. So x squared times everything, and then 6x times everything, and then 9 times everything. And combine your like terms, and this is what you would get. It has degree 4, and the zeros are -3, the multiplicity of 2, -2, and -1. Starting with 17, you're going to want to use a calculator. So for 17, the function is x to the third plus 6x squared minus 9x, and then minus 54. You can take a look at the graph. We're looking for real zeros here, and it looks like they would be at -6, -3, and +3. I can check that on the table. -3, can go up. So -6, -3, and +3. It's to the third power, so I'm only looking for 3 zeros. So my answer for that would be C. 18 is x to the third minus 8x squared plus 11x plus 20. All right, graph that, 20, not 2. And those zeros are at -1, 1, 2, 3, 4, and 5. And you can also check those at the table to make sure. -1, 4, and 5. -1, 4, and 5. All right, number 19. Clear it out. 2x to the third plus 5x squared minus 14x minus 8. Graph that. All right, -4 and 2 are definitely two of them. Let me check on the table. -4 is a 0, +2 is a 0. The other one is at, if I look at the graph, if I do second trace 2, I need a left bound for this one. So left of that 0 point and a right bound. And I get that this is at -1/2. So -4, -1/2, and +2. So that would be C. That's how you're going to do the rest of them from here on out, either by doing a left bound and right bound and finding the zeros, or by using the table of your calculator. So I think that pretty much explains the rest of them. You should be able to check the answers on the back. If you have any questions, let me know.